Ever wondered how our body reacts to foreign substances? Today, we dive into the world of hypersensitivity reactions. These are unique responses by our immune system when it encounters certain foreign substances or allergens. It's like our body's overzealous defense mechanism, which sometimes causes more harm than good. There are 4 types of hypersensitivity reactions, each with its own distinct characteristics and mechanisms. We have type 1, mediated by a protein called IgE, which triggers mast cell activation. Then there's type 2 and 3, both mediated by another protein, IgG. Type 2 targets cell surface or matrix antigens, while type 3 focuses on soluble antigens. Lastly, we have type 4, the only T-cell mediated reaction among the 4. And it's a bit more complex, with 3 different subgroups. Now that we have an overview, let's delve deeper into each type. Starting off with type 1 hypersensitivity reaction, also known as immediate hypersensitivity. In this interaction, our immune system meets an allergen, a foreign substance that triggers an allergic reaction. The immune system responds by producing a specific type of antibody known as immunoglobulin E, or IgE for short. This IgE plays a key role in allergic reactions. It binds to the allergen and also to a type of immune cell called a mast cell. This binding stimulates the mast cell to release a cascade of chemicals, including histamine, which are responsible for the symptoms we often associate with allergies, such as itching, redness, and swelling. These reactions can occur within minutes of exposure to the allergen, hence the term immediate hypersensitivity. This rapid response distinguishes type 1 hypersensitivity from other types of hypersensitivity reactions. So that was the immediate reaction. Next, we uncover the type 2 reaction. Moving on to type 2 hypersensitivity reaction, characterized by its reaction to cell surface or matrix antigens. In this type, our immune system mistakenly identifies normal, healthy cells as a threat and attacks them. The key player here is the immunoglobulin G, or IgG, a type of antibody that our body produces. Now, what happens is, these IgG antibodies recognize and bind to antigens present on the surface of our own cells or tissues. This could be anywhere in our body, from red blood cells to the cells in our kidneys or lungs. This binding triggers a series of reactions, leading to cell destruction, inflammation, or impaired cell function. While this reaction is essential in defense against some infections, it can also be the root cause of numerous autoimmune disorders, where the body's defense system turns against itself. So it's a delicate balance that our immune system needs to maintain. After understanding type 2 reactions, it's time to explore type 3 reactions. Now we come to type 3 hypersensitivity reaction, known for its reaction against soluble antigens. Here's how it works. The immune system produces antibodies, specifically IgG, in response to these soluble antigens. These antigens could be anywhere, in the blood, on the surfaces of cells, or even just floating around in the body's fluids. When these antibodies bind to their corresponding antigens, they form immune complexes. Now, these immune complexes are not inherently harmful. In fact, they're part of the body's normal response to invading pathogens. However, when they accumulate in excess, problems arise. The immune complexes can deposit in various tissues such as the kidneys, joints, skin, or blood vessels, triggering inflammation. This inflammation, while meant to protect the body, ends up causing tissue damage. This is the paradox of type 3 hypersensitivity reactions, a protective immune response transformed into an agent of harm. It's a fascinating, if somewhat unsettling, aspect of our body's defense mechanisms. Having covered the first 3 types, we now move on to the last type, type 4 reaction. Last but not least, we have type 4 hypersensitivity reaction, which is T-cell mediated. This type of hypersensitivity reaction is unique, as it's the only one that isn't mediated by antibodies. Instead, it relies on our immune system's T-cells. Let's break it down a bit. Type IV hypersensitivity reactions can be subdivided into 3 groups: each causing tissue damage in a different way. In the first group, tissue damage is caused by the activation of macrophages by Th1 cells. When Th1 cells activate these macrophages, it results in an inflammatory response. Picture a battlefield where Th1 cells are the generals, giving orders to the soldier-like macrophages to attack, leading to the chaos and destruction that we know as inflammation. Now onto the second group. Here, the damage is caused by the activation by Th2 cells of inflammatory responses, where eosinophils predominate. Think of Th2 cells as the puppet masters, pulling the strings of the eosinophils, leading to a specific type of inflammatory response. This is a different kind of chaos on our battlefield, but destruction is still the end result. Finally, in the third group, the damage is caused directly by cytotoxic T cells, or CTLs for short. These are the lone wolves of the immune system, acting independently to cause tissue damage. Imagine a covert operative on our battlefield, quietly and efficiently causing destruction. Now, let's talk about autoimmunity. It's believed that adaptive immune responses are initiated in the same way as autoimmunity, through the activation of antigen-specific T cells. These T cell responses to self-antigens can cause tissue damage, both directly and indirectly. It's a delicate balance, and when it tips the wrong way, we can see lasting tissue damage that can lead to serious health issues. With that, we've covered all 4 types of hypersensitivity reactions. It's a complex and intricate system, with each type playing its own unique role in the immune response. It's our own personal army, working tirelessly to protect us from harm. But when it goes awry, it can lead to the battles of hypersensitivity reactions we've explored today. We have now explored all 4 types of hypersensitivity reactions. To recap, Type 1 is mediated by IgE, which triggers mast-cell activation. Type 2 and 3 are driven by IgG, which can engage Fc-receptor and complement-mediated effector mechanisms. In Type 2, the reactions are aimed at cell surface or matrix antigens, while Type 3 targets soluble antigens, with tissue damage caused by immune complexes. Type 4, on the other hand, is T-cell mediated and can be divided into 3 groups. The first group involves tissue damage caused by the activation of macrophages by Th1 cells, resulting in an inflammatory response. The second group includes damage caused by Th2 cells, activating inflammatory responses where eosinophils predominate. The third group involves damage caused directly by cytotoxic T cells. Remember, these reactions are not just biological phenomena, but they are essential components of our immune response, helping our bodies to defend against foreign substances. Thank you for joining us in this journey through hypersensitivity reactions. Remember, each of these reactions plays a vital role in how our bodies react to foreign substances.